In the previous video, we talked about how we can find the coordinates of a stationary point. Right now, what we're sort of trying to do is we're sort of trying to understand how we can find the nature of the stationary point. How can we know if it's the stationary point is on the top of a hill or if the stationary point is on the bottom of a valley? So that's what we're trying to find out. And this sort of stationary point means a maxima. This sort of stationary point means a minima. The way we can find them is we basically use something called the double derivative, which we basically write as d squared y over dx squared. And the way we do that is, well, basically we first have our y, and then we differentiate it to get dy by dx. And once you differentiate it again, you basically get this double derivative. And with a double derivative, what you can sort of do is you can basically, whatever your x coordinate was for the stationary point. So let's say if this was your curve, and you sort of found the x coordinate of the stationary point. And then what you do is you sort of plug this x coordinate into the equation of this double derivative. So this double derivative will have some equation. If you plug the x coordinate into that equation, if you get a positive answer, then you basically have a minima. And then if you have a negative answer, then that means you have a maximum. And you can sort of understand that as positive basically means having a happy face, whereas negative sort of means having a sad face. And so this stationary points just corresponds to this point being at the lowest of this curve, and then this point being at the highest point of this curve. So again, let me just clear out what we're doing over here. So you basically find the x coordinate of your stationary point, and then what you do is you plug that x coordinate into the double derivative equation. Now the answer, if it's positive, it'll tell you if you have a minimum point. If it's negative, it'll tell you if you have a maximum point. Now let's practice out an example over here and see how is this done. So we can see we have this equation over here, and I'm just going to walk you guys through what a double derivative looks like in function notations. We know that we have y. When we differentiate it, we get dy by dx. In function notations, this would be f of x, and then you differentiate this would be f prime of x. Now once you differentiate this guy, this becomes d squared y over dx squared, that's the double derivative. And when you differentiate this guy, this becomes f prime prime of x. So both of these things mean double derivative, it's just different notations. Now we have sort of this function curve over here, which is f of x equals x cubed minus 2x squared plus x. And they ask us to find the value of f of x. Okay, so we need to find f of x at the two stationary points of the curve, and we also need to determine the nature of the stationary point. So the first thing that they tell us is that we have two stationary points, not just one. So that's what we're dealing with over here. And then we need to state the coordinates. We need to tell them we need to tell them this f of x of the two stationary points. So what that means is that basically if this equation instead of f of x, you had this equation in terms of y, then what they're really asking for is they're telling you that there's two stationary points. You need to give the y values for those two stationary points. And then what you also need to do is you also need to determine the nature of those stationary points. So you have to tell if they're a maximum or if they're a minimum. So that's what we're trying to do. So how we're going to do that is we are basically going to first go ahead and find out the y values or the f of x of the two stationary points. And the way we do that is we have our equation over here. What we're going to do is we are going to differentiate this. And when we differentiate this, this is just going to become f prime of x. And then you have to differentiate all of that. So this is going to be 3x squared minus 4x plus 1. Once you have all of this, you know that this is basically the equation for your dy by dx or your f prime of x. And you know what this represents. This represents the gradient. Now, the way you will find the y values for those stationary points is you do the following. So you know that the gradient of the stationary point is basically 0. So what you do is you plug the 0 in here. You plug the 0 in here, and then you basically solve out this equation over here. And you can see this is a quadratic equation because this thing has a square on top of it. And so what we're going to do is we're basically going to solve a quadratic equation over here. So one way we can do that is we can apply the quadratic formula. Another way we can do that is we can basically use the completing square method, and I think, or you can apply middle term break, and I think I'm going to apply the middle term break over here. So this is 3, this is 1. You multiply 3 with 1, basically get 3. And you need to find two numbers that are going to multiply to give you positive 3, but that are going to add up to give you negative 4. So I think if you multiply negative 3 and negative 1, you get positive 3. If you add them, you're going to get negative 4. So that's what I'm going to do. So it's 3x squared minus 3x minus x, which is basically this 1. It's going to be 1x is just x. So minus x plus 1. And then we're just going to start taking out commons over here. So we're going to get 3x from this side. We're going to get x minus 1 over here. And then we can take common from this side. So something that we can take common is negative 1. And then we'll basically be left with x minus 1. And then we can basically have 3x minus 1 as well as x minus 1. Now, what we can sort of do is we can solve out these guys. So this would just be 3x minus 1 equals 0 and x minus 1 equals 0. So one of the coordinates is x equals 1. The other coordinate is x equals 1 by 3. So these are the two x coordinates of the two stationary points. So again, what we did was we basically had this equation for the derivative, or in other words, the gradient of the graph. what we used over here was we used this idea that the gradient at the stationary point is 0. So we plugged that thing in here, and we basically got the two x coordinates for those stationary points. And over here we have those two x coordinates. Now they don't want the x coordinates, they want the y coordinates or the f of x. So the way you find that is basically you go back to this original equation and you put in those two x coordinates. So you put in 1 by 3 and you put in 1 in here. So let's do that. We have our f of x. Wait, so we're going to put 1 in here first. So we're going to get, oops, in place of x I'm going to have 1, and this is also going to be 1. So this is going to solve out to give us 1 minus 2 plus 1. So this is just going to be this one and this one are going to add up to give you 2, and then subtract 2 from that, you'll get 0. So one of your values is 0, and then the other value, we can find that out by putting 1 by 3 in here. This is just going to be 1 by 3 cubed minus 2, 1 by 3 squared plus 1 by 3. Let's solve this guy out. And this is going to be 1 over 27 minus 2 over 9 plus 1 by 3. And you can sort of put this in your calculator and solve this out, and you will get 4 by 27 as your answer. So this thing is actually equal to 4 by 27. So the two f of x, or the two y values for the stationary points, are 0 and 4 by 27. Now the problem is, see, we don't know if this thing is like this or if this thing is like this. We don't know if this hump, this 4 by 27, is like this or if it's like this. So what we actually need to do is we actually need to confirm the nature of these stationary points as well. And the way we do that is we use the double derivative. So that's what we're going to do. So what we have over here is we have our two x coordinates for the stationary point, which are 1 by 3 and 1. And what we're going to do is we're basically going to take our derivative equation and we are going to differentiate it again. And it's become f prime prime of x. So this is the double derivative equation now. And then you differentiate all of this. So this is just going to be 6x minus 4 plus 0, and I don't even need to write that. So this is my double derivative equation. Now what does this equation do? This equation tells us the nature of the stationary points. So we have two stationary points. One is at x equals 1 by 3. The other is at x equals 1. Let's put those guys in here and check out the nature of our stationary point. So we are going to have this first point, which is 1. This is going to be 6 multiplied by 1 minus 4. So this is just going to give you 6. 6 minus 4 is going to give you positive 2. So that means that the stationary point at x equals 1. So this station, we put x equals 1 in here. So the stationary point at x equals 1 is basically a minima. So positive, we know what a positive value means. A positive value means you have a smiley face. So at the bottom of that smiley face, you basically have a minima. So the stationary point at x equals 1 is a minima. And now we're going to find out what the stationary point at x equals 1 by 3 is. So we can do that. I can make some room for that over here. It's going to erase all of this stuff. Okay, so we have x equals 1 by 3. So we got this equation f prime prime. We're going to put 1 by 3 in here. So we'll get 6 over 1 by 3 minus 4. Now what's going to happen is this 3 is going to cancel out with that 6, and it's going to leave a 2 over there. And then that 2 multiplies with that 1, so you have a 2, and you subtract the 4 from a 2. So what you're going to get is you're going to get a negative 2 over here. And negative symbol basically means a sad face, right? Negativity means sad face. And so your stationary point is a maxima. It's a maxima. And so the stationary point at x equals 1 by 3 is a maxima. And so that's how you decide the nature of the stationary point. That's how you tell if it's a maxima or a minima. Now, how do you do that again? You basically make use of this double derivative, this f prime prime of x, or in other notation, d squared y over dx squared. These are the double derivatives. This is how you discover the nature of a stationary point. Now, having this tool in your arsenal, I would like you guys to go on and practice a lot of questions where you have to sort of determine the nature of stationary points.